Hello, everyone. Once again, it's calculation time with Dr. Dave. In this session, we'll be looking at semi-solids. What are semi-solids and how do we prepare them? Let me start by saying what you might already know. You most likely had in one of your science classes that we had three-state matter. We had solid, we had liquid, and we had a gas. Right? And in our case, I think now they even have plasma, but we have now our category that we use in pharmacy is the semi-solids. The semi-solids are right here between the solid and the liquid. They're semi-solids, right? For intents and purposes that we talk about, we're talking about creams, ointments, gels, lotions, that sort of thing. Usually there, you'll see. Now, the question is, well, once we know what these semi-solids are, how do we prepare them? So we can prepare them in one of two methods. The first method we're going to talk about is where you get the non-medicated base. And by non-medicated base, I mean the non-medicated gel, the non-medicated cream, the non-medicated ointment. No drug, just the base, just that ointment that's semi-solid. And to that, you're going to add a powder, which is a drug, or you're going to add the drug in a liquid form. So I can take the drug in a powdered form and mix it in with the base, or I can take a liquid that's a drug and I can mix that into the base. And that's how we make medicated semi-solids. Let me give you an example of what I mean there. You'll see in this first example that's listed here, it says that we want to make a 7% salicylic acid ointment. First, we have to understand what that means. And it says we're not just going to make some amount, we want to make exactly 60 grams of it. So how do we go about doing that? Let me show you an example here. So this is a commercially available product that you'll see here. It says 6% weight in weight. Ours is going to be 7% weight in weight salicylic acid. The way in which it's made conceptual wise is that you are going to take some amount of the ointment and some amount of the salicylic acid, and we are going to mix these together. And when we mix those together, we're going to get 60 grams of product. So we have to answer two things. How much of this and how much of this do we need? So that when we mix them together, we have a 7% salicylic acid and 60 grams total. So let's work out the first thing. How much drug do we need? The 7% means that we have 7 grams of salicylic acid in every 100 grams of ointment. And I'm going to rephrase this and say the word medicated ointment, because this is the final amount in 100 grams of the medicated ointment, not plain ointment. So 7% means 7 grams in the total 100 grams of product. So every time I want to make 100 grams of the medicated ointment, I need to put 7 grams of salicylic acid into it. In our case, we're not making 100 grams, we're making 60 grams of the medicated ointment. In this case, if I take my calculator and I know that I need 7 grams, right, of salicylic acid every time I want to make 100 grams of product, I don't want to make 60, I need 4.2 grams of salicylic acid. So in my picture here that I was drawing earlier, I need 4.2. So now I know what I need. I need 4.2. Right? I need 4.2 grams of salicylic acid. But how much of this do I need? How much ointment do I need? Well, that's the next step. We do know that if I take my 4.2 grams here and I add it to something here, I know the total has to be 60, because the ointment base plus the drug has to equal 60 grams total. So in this case, that's what we're going to do. We know that we want to make 60 grams, right, of the medicated ointment. We know that 4.2 grams, right, is going to be the salicylic acid. So if I take 60 grams and I minus by 4.2, I know I have to put 55.8 of non-medicated, I'll call it the non-med ointment. So in our picture here, I'm going to put 55.8 grams of this ointment. I'm going to mix it with 4.2 grams of this, and I'm going to get 60 grams total. That's how I would make 60 grams of a 7% salicylic acid. Let's look at another example that has a few other ingredients in there and how we would go about approaching this. This one says we're going to make salicylic acid. It's going to be mixed with white petrolatum, which is an ointment. Most people might see it as Vaseline. And anytime we put a dry powder like salicylic acid into something that's a semi-solid, like a white petrolatum or ointment or gel, we like to wet it first. We like to what we call levigate it. We're going to do that with this other ingredient, which is mineral oil, which is an oil that will mix well with the white petrolatum. So the way in which this prescription is showing us for compounded preparation is that we need 3 grams of salicylic acid. We're going to mix that with 3 mLs of mineral oil. Once we've mixed that and we levigate it, which is another way of saying that we're wetting it and breaking down those particles, we're going to add it into white petrolatum. We're not going to add it to 50 grams of white petrolatum. We're going to add it so that we QS to 50 grams, which means the total amount that we make is 50 grams. So we have to subtract out the weight of the salicylic acid and the weight of mineral oil to know how much white petrolatum that we need to do. Just like we did in this example here where we subtract out the drug. Now we're going to subtract out the drug, but then we're also going to subtract out the mineral oil. This one gets a little bit complicated because when we subtract out mineral oil, this says mLs, but everything we're making is in grams, right? So how do we go about doing that? Let's break that down into each one of its sections here. Let's start with the drug. We know it says 3 grams of salicylic acid is going to be made every time we make 50 grams total. But notice in the question here, it says we want to make 30 grams, not 50. We want to make 30. So how much salicylic acid do we need? So I'm going to put, let me get there. So we have salicylic acid, right? This says that we have 3 grams of salicylic acid every time we make 50 grams total. In our case, we are making 30 grams total. That's what we want. If I take my 3 divided by 50 times my 30, I get 1.8. So this is 1.8 grams of salicylic acid. That's how much salicylic acid I need to weigh out. The next thing I need to do is mineral oil. This says for mineral oil, that MO for mineral oil, this says I need 3 mLs of mineral oil every time I want to make 50 grams total of the ointment. In our case, we only want to make 30 grams total. So how much mineral oil do we need? 3, right, divided by 50 times 30, we need 1.8 mLs. Mineral oil. Okay, that works out fine, but the only thing is that when we go to the last thing, which is white petrolatum, how much white petrolatum do we need to weigh out? We know that the total amount has to weigh, right, in our case 30 grams, but we have 1.8 grams, right? So we know that the total amount that we want to make is 30 grams total, right? We know that we're going to subtract 1.8 grams, which is salicylic acid. Then we also want to subtract a certain amount of mineral oil. We're not going to say 1.8 mLs because we need it to be in grams. How do we take the 1.8 and turn it into grams? We use the specific gravity or density, which is given to us 0.85 as specific gravity. What does 0.85 mean? What does 0.85 mean for specific gravity? Well, that means that there's 0.85, we're going to call it grams per ml. So that means every ml weighs every ml weighs 0.85 grams. If I have 1.8 mLs, how much does that weigh? Well, 0.85 times 1.8 is equal to, do it again, 0.85 times 1.8 is going to equal 1.53 grams. That's how much it equals. Okay, so now down here, we're going to say that this is 1.53 grams of mineral oil. And now we have everything in grams. We can start our subtraction. We're going to do 30 minus our 1.8, which is the amount of salicylic acid, minus our 1.53, and we get 26.67. And this is the amount of grams of white petrolatum. Now, working all the way backwards, if we wanted to, we can look at our situation and say if I take 26.67 grams of white petrolatum, I mix it with 1.53 grams of mineral oil, and I mix it with 1.8 grams of salicylic acid, I'll get 30 grams total. And that allows us to find the three amounts for our ingredients. And you can also get the concentration of that, right? In our final preparation, you know that there's this amount of drug in 30 grams. You can get the concentration of that, right? It's not asked, but if 1.8 grams of salicylic acid is in 30 grams, how much is in 100 grams? We've got 6. So this is a 6% salicylic acid. That's like the one in the picture that I just showed you. So we can also at times add the drug into a medicated base. So we might have a situation where we have a base that already has something in it and we want to add a drug into it. And it might show in different ways. Instead of giving us specific grams or something, it might show parts. As you hear in this example, we want salicylic acid to be mixed with a paste. The paste is zinc oxide paste, so the zinc oxide is already made with the paste, so that's a medicated base. But our options is that we want to also add on top of that some salicylic acid. But the recipe, our directions, says that we should have 20 parts salicylic acid to every 980 parts of zinc oxide paste. So if we want to make 50 grams, how the heck do we know how much salicylic acid and how much zinc oxide we need? So let's break it down and let's put this into language that we might understand, especially when we're looking at parts. If we're looking at parts and it says 50 grams, let's make these parts for our purposes say grams. So now if it says that I need 20 grams of salicylic acid every time I have 980 grams of zinc oxide, right? Paste. I can use that as a ratio. If I've got 20 grams of salicylic acid and I mixed it with 90 or 980 grams of zinc oxide, I would get what? I would get 20 plus 980 would give me 1,000 grams, right? This would be 1,000 grams. This is also saying total parts, right? Because 20 parts is salicylic acid, 980 parts is zinc oxide. Total amount, total parts that I see in my example is 1,000 parts. Or I can say 1,000 grams total. So how do we break this down for our question? We want to know how much salicylic acid and how much zinc oxide ointment or zinc oxide paste we need to use. So for the salicylic acid, it says that we need 20 grams of salicylic acid, right? Every time we want to make 1,000 grams total, right? If I want to make 50 grams total parts, what do I need? So I've got my 20, right? divided by 1,000 times my 50, I get 1. This is 1 gram of salicylic acid. The next one is the zinc oxide paste. All right, so zinc oxide paste, my zinc oxide paste. What do I need this? This says I need 980 grams every time I want to make 1,000 grams total. If I only want to make 50 grams total, what do I need? Well, I've got 980, right? Every time I want to make 1,000, I want to make 50, I need 49, right? Of zinc oxide paste. And that should make sense because 49 plus 1 gives me my 50, right? 49 grams plus 1 gram of salicylic acid gives my 50. So don't get confused by the word parts if you see that, right? You're still using those common units that we have in terms of our grams to make 50 grams. And it can be different parts. If you want to say 50 milligrams, you'd use milligrams, so whatever the parts is saying to you. So notice the difference between parts of the ingredients as well as parts total. That's important when we look at all these types of examples. Now, I said in the beginning of this that there's 2 ways to really make semi-solid preparations. One of them is that we can take a non-medicated base and we can add the drugs to them, either in a liquid or in a powder form. Or the second way, what we're going to look at, is that you can take medicated ointment bases and mix them with other medicated ointment bases or plain ointment bases in certain ratios and get what we need. So what we're doing is, in our first case, we're looking at different strengths. So they're the same medication, but just in different strengths. And we can dilute them or mix them together to get a strength that we need somewhere in the middle. We're going to look at 2 new words, and it doesn't really matter if you know the words as long as you know how to do what they're trying to say. There's something called alligation medial and alligation alternate. We're going to use alligation medial, which is just a fancy word for doing something you probably already know what to do. Alligation medial is used when we are going to mix concentrations of semi-solids and we want to know what the final mixture will be. So in a pictured form, if I had a 5% cream, a 10% cream, and a 20% cream, and I mixed a certain amount of this, I mixed a certain amount of this, and I mixed a certain amount of that, what would be the final concentration of that mixture? If I have 3 different amounts, X, Y, and Z, that I mix 3 different concentrations, 3 different amounts, and it can be more than that. But in our case, we're going to look at 3. So let's look at an example with numbers here. It says, what is the percent zinc oxide in ointment? It's prepared by mixing 200 grams of the 10, 50 grams of the 20, and 100 grams of the 5. Right? So 250 and 1 is what we're looking at. So let's set it up where we break these down. The easiest way to keep track of this is to do the concentration and then we want to know what's the amount, I call amount of drug, or the amount of active ingredient, and this is going to be the amount of material it is, and I'll show you what I mean by that. So let's take the first one. It's 200 grams of a 10% zinc oxide ointment. So let's write the concentration, which is 10 grams per every 100 grams. Notice, right? 200 grams of zinc oxide, 10%. So 10% means 10 grams out of 100 grams. And I've got 200 grams. So if I take my 10 gram out of 100 and I multiply that by 200, I've got 20. This is the amount of drug I got. I have 20 grams of the zinc oxide here. How much material was that? That was 200 grams. The next thing I'm going to do is the next one. I'm going to look at the 20% zinc oxide. 20% is 20 grams in 100 grams. In this case, I'm only taking 50 grams of that material. Since I'm taking 50 grams of the material, I know that this is 50 grams total, right? That's how much material I did. But what's what's the amount of drug? There's 20 grams of drug in every 100, and I'm only taking 50. I'm going to have 10 grams of drug of the zinc oxide. And the last one is going to be a 5%, so that's 5 grams in every 100 ml, or about 100 grams. That's my concentration. This is how much of that I'm going to take. I'm going to take 100 grams of that. So I'm taking 100 grams of that material. 5 grams is out of 100. Multiply that by 100, I get 5 grams. That would make sense. 5 grams of the zinc oxide. How much total amount of material was that? That was 100 grams. Once I have that, now I'm going to be asked, the question is, what is the final concentration, right? What is the percentage of zinc oxide, right, in an ointment that's prepared by mixing these three? So what's the final percentage? In order to get a percentage, I need two things. I need to know the amount of drug, and I need to know the amount of material that the drug is in. So the amount of drug, or the amount of material that I have right here, if you look at it, is this first column. So if I take 20 plus 10 plus 5, I'm going to have 35 here. This is 35 grams of zinc oxide. If I take the second total here, I've got 350 grams of material. All right, 200 plus 50 plus 100. That's all I need to know to get my concentration. My concentration says that there's 35 grams of the zinc oxide in every 350 grams total. How much if I want out of 100 grams total, right? That's how we get our percent. So let's take our calculator. We have 35 grams of drug in the 350 grams total. Times that by 100. Let's do that one more time. We've got 35 grams of drug in 350 times the 100, and we've got a 10%. So this is a 10% zinc oxide is what the final concentration would be if we mixed 200 grams of the 10%, 50 grams of the 20%, and 100 grams of the 5%. This is the alligation medial. You're adding up the concentrations. Really what you're doing is you're adding up the amount of drug, and then you're adding up the total material, and you're finding the new concentration. Here's another example. What's the percentage of hydrocortisone if you mix 6 grams of an 8 with 9 grams of a 4 and 10 grams of non-medicated base? So here we're taking 3 things. One of them is just the base. There's no drug inside of it, but nothing changes. We do the same exact thing that we did above. We find out what's the concentration. We find out what the concentration is. We find out what is the amount of drug. And we find the amount of material, right? Amount of material. So the first one is we have 8% hydrocortisone cream. We take 6 grams of it. 8% means that we have 8 grams of drug in every 100 grams. We are doing 6 grams of that one. So taking our number, we've got 8 grams in 100. What happens if we only do 6? We got 0.48 grams of drug, but the amount of material we have was 6 grams. The next one says we've got 4%, so it's 4 grams out of 100 grams total. And our amount that we're using is 9 grams total. And this is 4 grams of, in our case, hydrocortisone. I should put the designation of what we're doing. Hydrocortisone. Hydrocortisone. So we know that there's 4 grams of hydrocortisone every time we have 100. We want to do it times 9 grams. That gives us 0.36 grams of hydrocortisone. The amount of material, 9 grams. And the last one is 10 grams of a non-medicated ointment. What's the concentration of some drug in a non-medicated ointment? It's 0 grams, right? Out of 100 grams total, right? There is no drug. So if there's 0 grams of hydrocortisone in 100 grams, how much is there if there's in 10 grams? There's 0. There's none. Nada. Zilch. But how much material did we add? We added 10 grams. So let's add up our columns. If we have the first column here, if we take 0.48 plus 0.36, we get 0.84. So that's 0.84 grams. Our last column is 10 grams of non-medicated plus 9 plus 6, right? We get 25 over here. So this is the amount of total material. This is the amount of drug, hydrocortisone. What's our final concentration? Total amount of drug. I'll do it in blue. Total amount of drug, 0.84 grams. Total amount of material, 25 grams. All right, times the 100, or 100 grams, right, total. This is a hydrocortisone. So there's 0.84 in 25. How much is there in 100? 3.36. This is 3.36% is what it would be. Okay. So that's alligation media, what we did. Fancy term for we're adding up the concentrations of the material that we're using to get a final concentration, right? Mixing different materials together. There's something that is also called alligation alternate. Alligation alternate is going to be used when we want to find the proportion of individual semisolids that are different concentrations to get a desired amount. So notice that in the alligation media, we just added a bunch of creams together and we said, what's the final concentration? Now I'm going to work the other way. I'm going to say, I want a final concentration to be X%. How much of these do I need to add to get that? There is a method that you can use which looks like this in this diagram here that you will see. This diagram can be used to solve these problems easily and organized. It's like a checkerboard, right? Tic-tac-toe. So you make your tic-tac-toe board, and on the top left, right, you only utilize a certain amounts here. On the top left here, not that. On the top left here, try to get a different color here. You put the highest strength of the material you have. So if you have a cream that's a 5% and a cream that's a 10%, you put the highest percent there. You put the lowest percent there. And in the middle, you have the amount that you're looking for. So if I had a 10% cream and a 5% cream and I want a 7% cream, my 10 would go here, and my 5 would go here, and my 7% would go here. That's how you set it up. The rest of it is doing the math to get it, and we'll look at how we get the parts of the high, the parts of the low, and how we get the total part. So let's look at an example. It's the easiest way to go about utilizing this. It says what ratio should a 5% and a 20% be mixed to prepare 10% zinc oxide ointment. Notice a few things here. It doesn't tell us a final amount to make. It's asking us in what ratio should they be mixed. What is a ratio? So how much 5 and how much 20% should you mix to get a 10% zinc oxide ointment? What ratio are those two being utilized? So let's start out with our checkerboard. In our top left of our checkerboard, we are going to put the highest amount that we have, the concentration. Notice it's 20%, so that's what I'm going to put there, 20%. My 20%. The lowest one goes on the bottom, 5%. That's what I got, 5%. And the last thing I put in is the middle, which is the desired percent. The desired percent in this case is 10%. So up here on the left goes the amount that we have highest. Down here is the amount that we have lowest. Keep in mind 0% could be used, like we had in the other example. That would be the lowest percent. And then the amount desired goes in the center. Now, what we do next is to fill in this one and this one. And this is the hardest part because it's just subtraction. So what we do is we take 20 minus 10. We keep the percents there. We're just taking the numbers now. 20 is the number minus 10. Number is 10. Let me write this here, 10. I went this way. Subtracted. Now I'm going to subtract this way. I'm going to take 5 from 10. I don't use the negative sign, right? So I'm going to say the biggest number, 10 minus 5, which is 5. That's it. And the last thing that I would do is that I would put down here the total of these, which is 15. And I'm going to put the word parts total. And I'm going to put parts. And I'm going to put parts. All right. Parts sounds scary, but don't worry. It's not that bad. What it's saying is that I am now going to read this. Right? The way I'm going to read this is across. So I am going to use this here, and I'm going to use this here. It says that I need 5 parts of the 20% every time I have 10 parts, right, of the 5%. So that's the ratio that I'm mixing them. I'm mixing them 5 parts of 20 to 10 parts of the 5 to get 15 parts total. So if I said for you to mix and make 15 grams of a 10% zinc oxide, you would mix 5 grams of the 20% with 10 grams of the 5%, and you would get an answer of 15 grams total. Now the question did say, what is the ratio of these two? So the ratio is the amount of zinc oxide, 5 and 20%. Well, we have 5 parts of the 20 to 10 parts of the 5%. We always like to keep this number being 1, so this can be a 1, right? 1 to 2 ratio. ratio strength that we have of what the products are in relation to each other. Notice here that we didn't use yet the 15 parts here. All right, we didn't use this yet, but we're going to be needing that based on what the question asks us. So let's go down to here. This question says how many grams of a 2.5% weight hydrocortisone cream must be mixed with 360 grams of a 0.025 cream to make a 1% hydrocortisone cream. Ooh, wow. That's a tough one, sounds like, right? So let's break this down. I'm going to use some visuals to help me with this one. It says that we want to take 360 grams, right, of a 0.25% cream. So I'm going to say we have 360 grams of some cream. We want to make, or mix rather, all right, a certain amount of grams of a 2.5% hydrocortisone cream so that we get a 1% hydrocortisone cream. So we have a concentrated 2.5% here. We have a less concentrated 0.25% hydrocortisone cream. We want to mix those together so that we get a 1% cream. Notice that the question is not asking us to make a certain amount. The question is asking us, how do we dilute, right? How do we dilute down the 2.5% so that, or I should say, how do we increase the percentage in this 360 grams that we're starting with? All right, this we don't know how much to add yet. So the final amount we don't know. We don't know what this final amount's going to be, but it's not asking us to make a final amount. It's asking us how much to add to the amount we have. All right. So let's set up our allegation. Let's set up our tic-tac-toe board here, and let's get started with what we may do. So if you see two concentrations like this is the best way to start because you have to do a mixture of them. So in our board, we take the top one and we put the highest concentration that we have. The highest concentration we have is 2.5, right? 2.5%. The lowest concentration is down here, 0.25%. Then we put our desired amount that we're looking for. We're looking for a 1%, right? Hydrocortisone cream. Then we do our subtraction, right? Then we do our subtraction this way, and we do our subtraction that way, right? So 2.5 minus 1 is 1.5, and 1 minus the 0.25 is equal to 0.75. And if I add these together, I'm going to get my 2.25. All right. So keep in mind that, like I said, sometimes we don't use all the information in this column. Let's look at what the question is asking us and see what we need. We're reading this across the way in which it would be here, right, and here. So it's saying that we need 0.75 parts, right, of the 2.5 every time we have 1.5 parts of the 0.25. Or if we don't like the word parts because it sounds scary, we say grams. Every time I have 1.5 grams of the 2.5, I'm going to mix it with 0.75 grams of the 2.5. Let me say that again. Every time I have 1.5 grams of the 2.5, I'm going to mix it with 0.75 grams of the 2.5. That mixture will give me a total of 200 or 2.25, right? Parts total. In this question, we don't need the parts total. We need these two top numbers. What do I mean? It says that our ratio What we're finding here is saying that I need 0.75 grams of the 2.5 strength, right? Every time I have 1.5 grams of the 0.25 strength. If I have 360 grams of that 0.25% strength, right? That'll tell me how many grams I need of the 2.5. So 0.75 divided by 1.5 times 360 is equal to 180. This is of the 2.5. Now keep in mind, this is not part of the equation. This is the unit description, right? Here, here, here. So don't add these in. You're looking at 0.75, 1.5, and 360. 180 grams of the 2.5. So if I was to take 180 grams of this 2.5, I can mix it with the 360, and that will give me a 1% cream. This will then be 540 grams total, right? 360 plus my 180 is going to equal that. So notice that this question is asking us to dilute down, or I should say increase up, the amount of drug in something given to us. Let's look at an example that now tells us a specific amount that we want to make. This says that we want to prepare 15 grams of a 0.5% salicylic acid using 2% and plain base. So we have 2% and we're going to dilute down. Draw our checkerboard. Here we go. In the top left, highest concentration we have, 2%. Lowest concentration we have is 0. Why? Because we have plain base, 0%. No drug in there. It's our lowest concentration. It's still the mixture that we're doing. What's the desired strength? 0.5%. Do our subtraction here and here. 2 minus 0.5, 1.5. 0.5 minus 0 is 0.5. These have units of parts, right? Parts. Add up our total parts. 2 parts total. Right? 1.5 plus 0.5, 2 parts total. Now, this says we want to prepare 15 grams of this. Now, as previously stated, we need 0.5 parts, or 0.5 grams of the 2% every time we have 1.5 of the 0. That's good. That's the relationship between the two of them. But we want now the total parts. We need this because we are being asked to make something. So this says that I need 0.5 grams, I'll write this in a different color, of the 2%, right? Every time I want to make 2 grams of the final product, right? The total parts here. If I am making 15 grams of the final product, right, how much do I need? Well, again, we take our 0.5 divided by 2 times the 15. That gives us 3.75. Now, this is 3.75 grams of the 2%. But how much base do I need to mix it with? How much plain ointment base do I need to mix it with? Well, I do the same exact thing down here. All right? This one is telling me that I need 1.5 grams of the 0%. All right? Every time I want to have 2 grams of final product. We want to make 15 grams of the final product. So in order to do that, we take our 1.5 grams every time we want to make 2 grams. When we want to make 15, I need 11.25. And this is of plain base. To check my math, if I was to add 11.25 plus 3.75, I should get 15 grams, which is what I'm being asked. All right, in the question. I would mix 3.7 grams, 3.75 grams of 2% plus 11.25 grams of the plain base. I'd get 15 grams total. We can increase this by saying, okay, instead of creams, we can also use drug powder. So the drug powder is what we can actually use instead of a medicated cream. Let's break this question down. It's saying how many grams of zinc oxide, now we have it as a powder form, should be added to 3,200 grams of a 5% to prepare a 20%. Doesn't give us a final amount because we're diluting there, we're adding to, I should say, the 3,200 grams. So always start with our little checker box in the top portion. We are going to add the highest amount. What is the highest amount of concentration? Is the zinc oxide powder? We're going to assume 100%. The lowest is the 20%. That's where the drug is coming from. The 5%, which is where the drug is coming from. That's the zinc oxide ointment. We're looking for 20%. And again, we're going to do our math subtraction down here and down here. So this would be 80, and 20 minus 5 would give us our 15. We don't need total parts down here, right? This is our total. We don't need this yet because we need the ratio between the two. In our case, it says that we need 15 grams of the powder every time we have 80 grams of the 5% cream. All right. Well, if we have 3,200 grams of that 5% cream, right, there's 15 grams of powder every time we have 80 of the cream. We've got 3,200 grams of the cream. We need 600. 600 milligrams of the zinc oxide powder. So if we mixed 600 milligrams of the zinc oxide powder in that 3,200 grams of the 5%, we would get our final 20% concentration. Now, we're not going to discuss it here, but there are times when you can mix 3 or more semi-solids together, right, to get a specified amount. Right? So let's say you had a 5, a 10, and a 30, and you wanted to make a 8.2%, right? That is something you can see in the book if you want to know how to do that. I don't care to do those calculations out because I think that most of the time you can do them with 2%. There are 2 different concentrations or use a powder. But you should be able to know what is feasible, right? So what do I mean by that? If you have 4 different concentrations of hydrocortisone cream in your pharmacy, so you have a 2, a 5, a 10, and a 25, right? Which ones could you mix in combination to make a 15%, right? So you have a 2%, you have a 5%, you've got a 10%, and you got a 25%. Which one of these can you mix if you want to just mix 2, right? To get to a 15%. I'm not asking you to do the math, I'm asking you to do which one's feasible. That's what I mean. It's usually not likely that you have to mix 3 things. Can I mix a 2 and a 5, right, to get a 15%? No, right? No, I can't do that. That's not going to work. Can I mix a 5 and a 10%, right, to get a 15%? No, it's not going to work either. Can I mix a 10 and a 25% to get a 15%? Yes, I can do that. The 15% has to lie between the 2 numbers, is what I'm saying. So you should know what's feasible. Not so much to do it on 3 or 4 different mixtures, which is possible to do, but usually not practical. And there are other combinations too, right? You can mix a 2% and a 25% to get the 15%? Yes, right, you can do that. And can you mix a 5% with a 25%? Yes, you can do this, right? Yes, you can get a 15% of it. So that's what I'm asking on this. All right. I know this section is usually a lot, but it's just in terms of knowing how to do two things, the alligation medial and alligation alternate. When you are doing the little checkboard combinations here, make you understand when you're using the ratio between the two versus when you have to use the total parts, right? Total parts is usually when you're being asked for a final amount to make. If you're trying to start with something and you just need to add something to it, usually you just need the ratio between the two. All right. So once again, that is the preparation of semi-solids. And this is, as you know, pharmacy calculations, and it's the most important class because it's the only one that counts.